In 2012, a landmark science paper presented the first high-coverage genome of a Denisovan individual, a young girl who lived 40,000 to 50,000 years ago in Siberia's Altai Mountains. Despite the unprecedented data quality, the authors concluded that she had dark pigmentation, brown hair, and brown eyes. This prediction, widely cited in the media, seemed definitive, but it wasn't accurate. The supplementary notes of the study wrote that the reliability of their prediction was very low. In fact, based on new analysis of the Denisova 3 genome, she wasn't a dark-skinned tropical hominin. She was a pale, light-eyed girl from the Altai, adapted to Siberian cold and cloud. What's more, she lived 60,000 to 80,000 years ago, not 50,000 years ago, contemporary with Neanderthals still present in the Altai. Indeed, the paper's supplementary tables reveal the Denisovan girl carried multiple light pigmentation alleles, including genes for blonde hair and even blue eyes. These genotypes, fixed in modern Northern Europeans, should have produced a pale, light-eyed phenotype. The contradiction arose from the study's analytical method. The team used a simple majority vote system based on counting genes into phenotypic bins such as fair versus dark or blue eyes versus not blue eyes. Despite the presence of powerful light-associated variants, they were outnumbered by ancestral alleles with less influential genes. The model lacked polygenic weighting, treating each gene equally regardless of effect size, and assumed archaic humans defaulted to dark pigmentation unless overwhelmingly contradicted. The final prediction, dark brown, thus stemmed not from absence of light alleles, but from a scoring system that failed to capture their dominance. Modern analyses using full polygenic models tell a different story. Applying weighted effect sizes to the same genome yields 80% probability of light to medium skin, light brown hair, and non-brown, likely hazel or light brown eyes. These findings suggest the Denisovan girl was adapted to high-latitude, low UV conditions, paler than equatorial early humans, and phenotypically closer to modern Europeans than previously thought. She was even light than some Neanderthals, especially those in southern Europe. The light pigmentation alleles were always present in the sequence. Only with improved statistical models and recognition of independent archaic adaptations did their significance emerge. Science, like evolution, refines itself over time. The Denisovan girl was not a dark-skinned relic of tropical ancestry. She was a pale, light-eyed child of the Ice Age North, her genome a testament to convergent evolution long before modern humans reached Siberia. Now that we have that out of the way. For more than 15 years, the Denisovans have haunted the scientific imagination. They immediately acquired an aura of mystery, partly because they revealed themselves genetically, with astonishing clarity long before their culture was understood. Their DNA was everywhere, in Tibet, in island Southeast Asia, and in the genomes of Aboriginal Australians and Papuans. Suddenly, a ghost population with no face took centre stage, overshadowing its sister lineage, the Neanderthals, and challenging the supposed uniqueness of modern humans. Popular articles began speaking of Denisovans as a highly skilled, advanced people who crafted jewellery of jade-green stone, tamed the inhospitable Siberian highlands, and traded materials over long distances. But this captivating picture may not survive close scientific scrutiny. The supposed proof of Denisovan sophistication, the famous green chloritolite bracelet from Denisova cave, does not in fact demonstrate Denisovan craftsmanship. When the archaeological context, stratigraphy, and radiometric modelling are examined carefully, the bracelet and its companion artifacts emerge not as Denisovan creations, but as tools most plausibly associated with early Homo sapiens. New work on stratigraphy reveals that Denisovan fossils within the same area are significantly older than the sediments in which they occur, indicating redeposition. This raises serious doubts about associating the bracelet with Denisovans at all. To understand the problem, we must begin with the specimen that brought Denisovans to scientific attention, Denisova 3. Found in the East Gallery of Denisova cave in southern Siberia, this tiny bone, the distal phalanx of a female child, showed clear Denisovan ancestry when its genome was sequenced in 2010. The revelation overturned long-held models of human evolution, yet Denisovans survived in Siberia until at least 40 to 50,000 years ago, overlapping both Neanderthals and modern humans. Their lingering presence in Siberia fueled speculation that they must have been capable competitors. Popular accounts quickly built a myth of Denisovans as rugged innovators who mastered the cold and engineered complex jewellery. Foremost among the evidence for their supposed ingenuity was the striking green bracelet from the cave. Polished with precision and drilled with a high-speed rotary technique, the artifact was heralded as the earliest masterpiece of personal ornamentation, more than 40,000 years old, and thus older than any modern human presence in the region. The problem with this narrative begins, and ultimately collapses, at the level of the cave stratigraphy. Denisova Cave is a complex site, comprising multiple chambers filled with layered sediments that accumulated over hundreds of thousands of years. Layer 11, the one central to this story, is subdivided into multiple sub-layers, each representing different depositional episodes. The Denisova 3 finger bone came from layer 11.2 of the east chamber, while the bracelet fragments were recovered from the lowermost portion of layer 11.1 of the same chamber. For years, researchers assumed that layer 11 dated broadly to the Middle-Upper Paleolithic transition, roughly 65,000 years ago. Under this assumption, one could imagine that the bracelet and the Denisovans lived around the same time. More recent modelling, however, has upended this interpretation. The layer sediments, when examined using Bayesian integration of radiocarbon and optical dating, appear younger than the Denisovan bone itself. In other words, Denisova 3 is substantially older than the deposit in which it was found, between about 55,000 and 80,000 years old. This age range suggests that her remains moved from their original context into younger sediment. The bracelet, meanwhile, fits more comfortably in the range of roughly 45,000 to 50,000 years old, a period now strongly associated with the first modern humans migrating through Eurasia. This discrepancy is crucial. The bone and the bracelet are not the same age. The child's finger predates the bracelet by tens of millennia. This means that the bracelet cannot be associated with Denisova 3 or any Denisovan individual merely on the basis of stratigraphy. If one holds the bracelet, one is not holding a Denisovan artifact. One is holding an object created by modern humans who arrived after Denisovans stopped inhabiting that chamber. Further context from the cave reinforces this conclusion. Early Upper Paleolithic artifacts date to about 39,000 to 49,000 years ago in the main chamber, 57,000 to 69,000 years ago in the east chamber, and 39,000 to 45,000 years ago in the south chamber, though layers in the east chamber show signs of disturbance. These assemblages show both blade production and Levallois technology, but as in earlier occupations, scrapers remain dominant. A more fully developed Upper Paleolithic bladelet technology, distinct from the scraper-rich horizons below, begins accumulating in the main chamber at roughly 32,000 to 40,000 years ago, neatly aligning with the widespread diffusion of Upper Paleolithic Homo sapiens. The Upper Paleolithic layers of the cave also contain several bone tools and ornaments: a marble ring, an ivory pendant, a red deer tooth pendant, an elk tooth pendant, the chloritolite bracelet, and a bone needle. This cluster of symbolic objects recalls the behavioral signature of early Homo sapiens elsewhere in Eurasia. Crucially, Denisovans are only confirmed to have inhabited the cave until roughly 55,000 years ago. The dating of these Upper Paleolithic artifacts thus overlaps strongly with the period of modern human migration into Siberia. However, direct fossil evidence of modern humans in Altai is lacking for this time window, and the only hominin specimen from these layers, Denisova 14, has DNA so degraded that its species identity cannot be confirmed. The artifact attribution therefore remains unresolved, but the strongest circumstantial evidence favours modern humans rather than Denisovans. The bracelet therefore loses its capacity to demonstrate Denisovan intelligence. Instead, it becomes another familiar data point in the archaeological record of early Homo sapiens. The manufacturing techniques, Finely bored holes, careful polishing and controlled shaping match well with the technological prowess documented for early modern humans elsewhere. These technical markers surpass what has ever been shown for Denisovans themselves, who left behind stone tools but no proven personal ornaments. The only reason anyone ever credited them with such symbolic sophistication was the assumption of co-occurrence. That assumption is now gone. In fact, anthropologists including Ludovic Slimak also question the attribution of symbolic thought to Neanderthals, arguing that many of the items that archaeologists suggest as being used for symbolic reasons, such as ochre, eagle talons and feathers, may have instead had practical uses or been made by Homo sapiens. For example, Slimak says that Arctic people pluck the feathers of birds to suck the marrow of the calamus, which is very nutritious, meaning Neanderthals were not wearing birds' feathers. Suddenly the whole theory of Neanderthal bird feather symbolism collapses. The Neanderthal wearing feathers turned out to be a caricature, said Slimak. Likewise, the eagle talons found in Croatia that have been suggested to have been a Neanderthal necklace could instead have been used for scraping tools. Shells with holes in them were not used on a necklace, he argues, because the holes were natural and not drilled. Ochre crayons had practical purposes and were not used for drawing pictures on cave walls. Other mysterious markings on cave walls can be attributed to accidental or utilitarian purposes by Neanderthals, or even animals. Slimak suggests that attributing doodles on cave walls to Neanderthal symbolism is monkey business. This doesn't make Neanderthals less intelligent, he says. It just means that symbolism was not important in the Neanderthal mind. Other claims about Denisovan cognitive capacity weaken under similar pressure. There are no other known Denisovan artworks, no engraved bone or ivory, no cave ceilings painted with ochre animals, no burial sites containing grave goods. Neanderthals, by contrast, show occasional artistic expression, though this is debated. Modern humans, even in their earliest expansions into Eurasia, are flamboyant by comparison. The Denisovan record is much poorer. In fact, all we know about Denisovan behaviour comes from stone tools, typical of Middle Paleolithic or Middle Paleolithic-like industries, and even those assemblages could have been produced by different archaic populations sharing the region across different periods. Nevertheless, Denisova III's genome is fascinating for its ancestral information. Her DNA reveals that her population interbred not only with Neanderthals, but also with the ancestors of modern human groups in Asia. She carried high-altitude adaptive variants, beneficial to later Himalayan peoples, and inherited from her lineage. Yet genetic adaptation does not equate to symbolic intelligence. Even animals evolve intense physiological specializations without achieving complex mental lives. The fact that Denisovans transferred beneficial variants into modern humans does not mean they invented mountaineering or engineered textiles suited to Himalayan cold. They merely survived in those places long enough to leave genetic traces. Genetic data cannot be substituted for archaeology. Denisova III's DNA does not sketch a cultural world. It only shows that Denisovans were genetically distinct, that they interbred with modern humans, and that after these contacts they eventually disappeared. In the realm of artifacts, they are silent. The re-evaluation of the bracelet's age and authorship weakens the few stories once told about Denisovan intelligence. If the most impressive object once linked to them is now understood as a product of Homo sapiens, then the Denisovan material record shrinks to something much more modest. Their tools appear crude relative to Upper Paleolithic industries. Their presence at Denisova Cave looks marginal and scattered across time. Their extinction, meanwhile, stands in stark contrast to the survival and expansion of modern humans. Even the celebrated Denisovan-Neanderthal hybrid, Denisova 11, tells a similar story. Although the existence of such hybrids is fascinating, nothing in the record suggests cultural exchange. There is no hybrid symbolic horizon, no indication of sharing artistic or technological traditions. The interbreeding looks sporadic and unstructured, a biological event rather than a social one. Given this limited cultural record, the persistence of tales about Denisovan brilliance says more about us than about them. We want the past to be strange and magnificent. We want ancient cousins who rival us, who write songs in lost languages and carve hidden jewels. The bracelet held that promise. Now it looks more like a mirror reflecting our own desires. Once the stratigraphy is properly understood, the bracelet belongs to modern humans moving across Siberia roughly 45 to 50,000 years ago. These are the same people who were making symbolic objects in the Levant and Europe, who were burning pigments, piercing animal teeth for necklaces, and engraving shapes into ivory. Attributing the bracelet to them is not just logical, it is consistent with their global archaeological signature. When they arrived at Denisova Cave, they did what they always did. They expressed themselves. In the end, Denisovans remained biologically fascinating but culturally opaque. They contributed genes but left no confirmed art. They survived in harsh environments but left no monuments of thought. Their disappearance, not their flourishing, is the defining feature of their history. Their legacy is genetic and invisible, not archaeological and symbolic. To strip them of unearned glory is not to diminish them, it simply restores the truth. They were one of many human lineages struggling for survival, equipped with the tools of their age but lacking the explosive creativity that allowed Homo sapiens to transform the world. The bracelet, once thought to be their crown, now looks instead like the banner of their successors. It is a reminder that symbolism, artistry, and technical ingenuity did not arise in a dozen places independently. They came with us. Denisovans disappear from the record as modern humans advance. Their caves fill with the artifacts of newcomers, the traces of minds turning objects into meaning. Even if the bracelet wasn't made by Denisovans, it is still the earliest example of this type of complex manufacturing of jewellery in the world. What looked like Denisovan genius was only a misunderstanding born of temporal overlap. When time is realigned, the bracelet's story resettles into familiar ground. It is ours. And the Denisovans, though intriguing, were never what we wanted them to be. They were not visionaries. They were not artists. They were not as smart as we once imagined. Thanks for watching.